VOR stands for VHF Omnidirectional Range. VHF stands for Very High Frequency, which makes a VOR only a short-range radio navigation system. In line of sight, VORs are receivable from 25 nanometer up to 140 nanometer usable radius. Line of sight meaning if there's a mountain between you and the VOR, you will not receive a reliable signal even though you are within the station range. VOR is a navigation system that uses radio transmission between a beacon on the ground and an instrument of an aeroplane. VORs provide azimuth information, the heading of the aircraft, and are generally used during the en route phase of flight or on non-precision approaches to a runway.
When a VOR is crossed with a DME, it is referred to as a VOR DME. It allows pilots to identify the aircraft's precise geographical location, including direction and distance to or from the station. On the other hand, when a VOR is crossed with a TACAN, it is referred to as a VORTAC. It is regarded as a unified navigational aid that functions continuously and offers all three services at all times. VORs are available in high, low, and terminal service volumes and dimensions. High-altitude VORs can be utilized up to 60,000 feet and 130 nautical miles wide. Low-altitude VORs serve aircraft up to 18,000 feet in height and 40 nautical miles in width. Terminal VORs may reach altitudes of 12,000 feet and have a range of 25 nautical miles. VOR coverage is often extensive along established visual flight rules and instrument flight rules routes. That is why the greater the distance between you and the VOR, the higher you must fly to receive signal reception. To accommodate geography and the curve of the Earth, VOR service volumes have a slope at the lowest altitude.
Instrument landing system could be found at most major airports around the world. Despite this proven system, there are also some drawbacks to ILS. The first one is glide slope component is dependent on surrounding terrain on the approach path terrain, and obstacles surrounding the airport can interfere with the glide slope and lead to potential operational limitations. The second one is the narrower beam projected by ILS means there is a relatively low area coverage for aircraft to intercept.
Potential for interference from nearby navigational stations. Due to the lower frequency band in which ILS operates, there is potential for interference if stations are positioned incorrectly. This is especially true for localizer stations. ILS ground infrastructure is bulky, consumes a large amount of airport real estate.
As the name suggests, automatic direction finder is used in many ways, such as for station passage. The ADF becomes more sensitive when an aircraft approaches an NDB station. Tiny lateral deviations result in considerable needle deflections, which occasionally exhibit abnormal left or right oscillations. This signals station passage and gives the navigator a precise position fix. Second, for tracking. The ADF can also be used to monitor a desired route while accounting for winds above, which could cause the aircraft to deviate from its trajectory. A pilot using proper pilotage procedures will figure out a corrective angle that perfectly balances the anticipated crosswind. The pilot uses the ADF to monitor the direction to or from the NDB as the airplane takes off and makes necessary corrections. The shortest route and travel time to the ADF's destination will result from a direct track.